Hello and welcome, my gentle and of course very modern apes. I've got a real special treat for you guys today.
Talented, brilliant, incredible, amazing, show-stopping, spectacular, never the same, totally unique.
In fact, this treat is so good, it's got me feeling like Santa Claus wriggling down your chimney to leave you the best present of all time, if your interests are encompassed by the very niche category of debunking young Earth creationism. Of course, the flip side of that coin is that to the young Earth creationists, I am Krampus, busting my way through the threshold of their abode and leaving them a hearty lump of peer review. Because what we're going to be doing today is systematically annihilating one of the most scientifically bankrupt claims made in young Earth creationism, that humans are only about 80% similar in our DNA to chimpanzees, made by a one Jeffery Tomkins.
I found out that the human and chimpanzee genomes were no more than 85% similar.
Now, at this point, you might be thinking, whoa, Gutsickgibbon, you're coming in a little hot here. This is pretty aggressive right off the bat, and that's not the Gutsickgibbon, the Erica that I'm used to, the one who's typically cordial and tries to give people the benefit of the doubt. This mean Erica is not the one I like so much. And what I would say to you with regard to that is, you're right. I dislike Jeffery Tomkins. I've read just about everything this man has ever put out with relation to the topic at hand today, and I think there's a bit of mischief afoot here. And you know how I feel about mischief in science. I hate it. Tomfoolery belongs on the playground, not in the lab, and certainly not in your supposedly peer-reviewed papers, as well as the number that hundreds, if not thousands, of creationists cite on the regular. Humans are only 80% similar to chimpanzees genomically. If you've been hopping around the debunking young Earth creationism scene for any modicum of time, you've probably heard this quip before. And you could also probably stand to develop some healthier hobbies. Of course, you know, stones and glass houses.
What? I love garbage.
Regardless of our mutual bad taste in pastimes, I'm sure you've heard that quote before, and I've heard it more times than I can count. It is parroted by just about every young Earth creationist organization out there. Answers in Genesis, Creation Ministries International, the Institute for Creation Research, and of course the oodles and oodles and oodles of devout followers of these organizations, your layman creationists, also love to spew it.
Based on new data in 2018, researchers have now shown that the maximum human and chimp DNA similarity is actually only 84%.
Even if you've heard it, so what? You might be thinking, who cares? What is the actual significance of this 80% number? What does it mean? Well, before we meticulously deconstruct this portion of Jeffery Tomkins' career, you need a little bit of background, okay? So strap in. We humans are apes. We are members of the superfamily Hominoidea and the family Hominidae. This means we are specifically great apes. The reason humans are classified this way is because we have all of the physical characteristics that designate our position with the other apes. Like them, we have internal tails, highly mobile shoulders, a Y5 molar pattern, dexterous hands and wrists, long gestations and long developmental periods, complex social systems, and large brains for our body sizes. We have all the same bones, muscles, and organs, and even our brains have all the same regions, with humans merely emphasizing portions related to cognition. This is why, although all great apes use tools, human tools are the most sophisticated. The difference between humans and other apes is one of degree, not kind. Get it? The fact that humans are so closely aligned with the other apes has actually been recognized for centuries, if not millennia. Linnaeus, the father of taxonomy and a creationist himself, even recognized this, choosing to elevate the other apes to our level rather than separate us out. Darwin fleshed this idea out, of course, and after decades of intense scrutiny, there can be no denying that humans are physically apes just as dogs are physically canines. But even with that understanding, it was thought that humans were a very distinct ape indeed. We thought ourselves an outlier, apes, if barely. And then along came genetics. Now, while everyone appreciated that humans were probably going to hash out as being closest to the apes, what no one really expected was how close we ended up being, and the final family tree was surprising to many. The human genome was sequenced in 2002 and the chimpanzee genome 3 years later in 2005. This allowed comparisons to be made in full rather than the shorter sections of the genomes that were being compared before, and the results were striking. In coding base pairs, that is, the regions of the genome that code for proteins, humans and chimpanzees were 98.8% similar. When indels were included, so a full genome-to-genome comparison, that number hashed out to be 96%. This is why you can get a couple of different numbers for the question how similar genomically are humans and chimpanzees. We're nearly 99% similar if we're only comparing coding base pairs within the genome, and we're around 95 to 96% similar when we're looking at the full genome with indels included. The fact that there are differing numbers isn't because people and scientists are changing their mind, it's because it depends on what we're actually comparing. What can be said for certain, though, is that the number is really high. In fact, humans and chimps are more similar genomically than African and Asian elephants are to one another. And not only that, but as more apes were sequenced, it came to be seen that humans aren't just most closely related to chimpanzees, but that chimpanzees are also most closely related to humans. This means that your genome, the individual watching this, has more in common with a random chimpanzee genome than any gorilla on the planet shares with that random chimp. The closest relative to humans and chimps as a pair is then gorillas, followed by orangutans, and then the gibbons. This comparative genomics work is effectively a souped-up version of a paternity test. The genome reveals how close two organisms or two species are, and humans are closest to panins, placing us not just with the other apes, but smack dab in the middle of the family Hominidae. Firmly apes, past the bananas. Creationists went absolutely ballistic at this. And this is because, according to certain, and in my opinion, myopic and incorrect interpretations of Genesis, the sort of Abrahamic God created humans literally in his image out of nothing around 6,000 years ago at the end of a sort of 5-day smorgasbord of creating things from like dirt and literally out of thin air.
Cringe.
But as I'm sure you can understand, it's very difficult to accept human evolution and common descent if you have this particular starting point, as it were. Many, in fact most, Christians and other religious folks make it work. Creationists do not. And so, after the human-chimp genomic similarity number was published around 2005, creationists suited up for several decades of unimaginative whinging. Because if humans are created in the literal image of God, why monkey? The number simply must be wrong somehow. First, they complained that the entire human genome and the entire chimpanzee genome weren't being compared, and this was actually true. When the human genome was officially sequenced, it wasn't actually completely sequenced. Known functional regions were, along with much of the majority functionless rest of the genome. The same thing happened with the chimpanzee genome. So when the comparison was made, functional regions were the focus since the entirety of these areas were complete and the rest of the genome was not known to have any explicit function. This is still generally the case, despite the fact that creationists will tell you the entire genome has been shown to be functional or we're moving towards the entire genome being shown to be functional. This is not true. The genome has enormous portions of it that are non-functional, and we know this thanks to knockout tests. You can take a mouse, knock out large portions of its genome, and it can still reproduce and have offspring and live a long life, and then it will die. And this is because the regions that are being knocked out don't do anything. No encodes work doesn't change this. You can see a video here by Dan of Creationists to explain in depth why. However, in the meantime, and when I say in the meantime, I mean just the past 2 or 3 years, the human genome has finally been completely sequenced. The chimpanzee genome isn't there yet, although a significantly larger portion of it is now known, and wouldn't you know it, the similarity between humans and chimps has actually gone up a little bit, not down. So then they claimed that the chimpanzee genome was actually biased in favor of the human genome, like it was artificially inflated because it had used the human genome as sort of a reference during its assembly. And there is some truth to that. The sort of humanization of some of these early great ape genomes is appreciated by the genetics community, as it were. And so what the genetics community did is they just were like, yeah, that's reasonable. Let's investigate it a little bit. And so they just assembled the great ape genome, specifically the chimp, without using the human scaffolds, like the human reference. And what they found is that the similarities stayed the same. For reference, we'll be using one of those non-humanized great ape genomes today. We're going to be using Pantros 6. So at this point, the creationists kind of split into two camps of cope. And the first of those camps is going to be the one that the intelligent design advocates and the old earthers join. And this is basically an acceptance of the number, that high similarity, with the stalwart caveat that it is due to common design, not common descent.
Okay.
Clever, you might muse. After all, a Honda and a Subaru SUV certainly share a lot of similarities, but it doesn't mean one literally descended from the other. They just share a lot because they perform similar functions. My brother in Christ, those are cars. Cars don't reproduce, and they don't pass down genetic information, the through line of which literally connects organisms in an ancestor-descendant relationship. But common design gets created as an argument by one simple observation in genetics, and that's that we see nested hierarchies formed not just by functional regions of the genome, but also by non-functional regions of the genome. It's one thing to argue common design on the basis of similar functions or similar morphologies. After all, these are reflected in the genome, and so it would be reasonable to suppose that if two organisms look similar, their genes should reflect that, and that could be due to common design. The problem with it is we have regions of the genome that do nothing at all. And those also form nested hierarchies. It's going to be very difficult to argue at this point common design without supposing that God just kind of is trolling people by creating the appearance of evolution in every facet of an organism's genome, but actually it wasn't evolution, it was him all along. God just likes messing with people, and specifically creationists, who are supposed to be like his favorite guys.
I thought it would be funny.
The young Earth creationist, faced with the continued validation of the high human-chimp genomic similarity, simply said that the number still wasn't right. And by they, I mean Jeffery Tomkins. Jeff did that. Who is Jeffery Tomkins, you might be wondering? Well, he's today's goofy antagonist, and he is perhaps one of my least favorite young Earth creationists.
You know what? I am not as mean as I would like to be. And I really wish people appreciated that more.
Jeffery Tomkins is a geneticist, so perfect background for not making rudimentary mistakes in the field of genetics. Tomkins got his master's in plant science from the University of Idaho in 1990, and then got his PhD in genetics from Clemson in 1996. That genetics work also evidently focused on plants, placing Tomkins firmly, I feel, in the plant geneticist category. Perfect background to be debunking the human-chimp genomic similarity. Two animals.
But anywho.
So now, like I said, humans and chimpanzees, genomically speaking, are about 98.8% similar when looking at coding base pairs, and when including indels, so basically whole genome comparison, that number's about 96%. And Jeff is the maddest individual on the planet at this number.
At that point, I realized there was some monkey business going on with chimpanzee DNA.
Right.
Research comparing it to human.
So much so that he has written numerous papers on the subject, along with a book. It's a picture book, but it's still a book. He's evidently devoted much of his career as a young Earth creationist scientist to debunking this number. He converted in his undergrad, and I guess he's been milling away at this. Some of the first stuff comes out around 2011, so a long, long time. He hates it. So while other creationists simply look at the number and they're like, it's common design, or there's another explanation for it. And again, I have my problems with those explanations as well. Tomkins just seethes and kicks his feet and says it's not true. Even other young Earth creationists know better than this. Todd Wood, who I love to gas up on this channel, is a young Earth creationist, and he looks at the number and he's like, yeah, he's even published in young Earth creationist circles that, guys, like, the number is legit. We're just gonna have to deal with it. Not Jeff, though. So, if humans aren't 96 to 98.8% similar, how similar are they, according to Jeffery Tomkins? Well, it depends on when you ask him the question and what methodology he's using, because I've heard everything from 70 to 89%, and it's all bullshit. I try my best not to swear on this channel. I like keeping things mostly professional, even if I am being sassy or including jokes in my videos, but there's really no other way to put it. It is the only word that accurately encompasses how I feel about the body of work that Jeffery Tomkins has put out. And I want to take you on a journey as to why. Now, I'm a primatologist. I got my master's of research in primatology, and my bachelor's was in animal science, specifically pre-professional animal science. So I was on the pre-vet track. I took a lot of STEM courses, Chem 1 and Chem 2 inorganic, Chem 1 and Chem 2 organic, Physics 1 and 2, biochemistry, and of course, genetics. But I am not a geneticist. I am genetics adjacent at best. But then, I'm not trying to debunk comparative genomics, am I? I'm at least qualified to take a look at the number and the work surrounding it. And what I think you'll find is that you don't need to be a geneticist to show why Jeffery Tomkins' work is bogus. That is not good. In fact, by the end of this, I think you'll have a pretty good idea as to how to run this stuff for yourself, so you can kind of cross-check me and cross-check Jeff. This is a dissection of the majority of a body of work concerning a specific topic by one guy. So what we're going to do is we're going to go through his papers. We're going to look at his methodology. We're going to compare it to normal comparative genomics, and we're going to run some tests for ourselves. For us, this journey begins in 2011. One of Jeffery Tomkins' first published works on the difference between humans and chimpanzees was the paper titled Genome-Wide DNA Alignment Similarity Identity for 40,000 Chimpanzee DNA Sequences Queried Against the Human Genome is 86 to 89%. You should know before we begin that all of Jeffery Tomkins' publications with regard to this subject were published in the Answers Research Journal, which is the young Earth creationist organization Answers in Genesis' journal that has no secular peer review and requires a young Earth creationist perspective. This piece was evidently put out in part as a response to Todd Wood, the much cooler young Earth creationist I mentioned earlier, who agreed that humans and chimpanzees do indeed hash out to be 96 to 98.8% similar when he ran some of these contiguous sequences himself. So Jeffery Tomkins maybe perhaps was triggered by this, and that's what caused him to just enter the fray on this subject, because remember, there's nothing that makes a creationist angrier than another creationist agreeing with conventional science. So, allow me to stop and explain a few things that are going to be very relevant for understanding the rest of the video and the significance of the work that I did. First, comparative genomics is the study of how entire genomes differ from one another. This can be done within a species, such as taking two humans for, say, a paternity test, or between species to determine how similar, closely related, they are. It is the same logic in both ways. This is rooted in pretty basic concepts. Genetic information is inherited from parent to offspring. Thus, organisms with more similar genomes are more closely related. As an aside, this is just another reason as to why common design fails so utterly as a scientific concept. It cannot readily distinguish what it accepts as common descent, such as dogs coming from wolves, and what it desperately needs to be common design, such as the similarity between humans and chimps.
Corporate needs you to find the differences between this picture and this picture. Intel has told us there are at least 7.
Okay, I already see one. Give them. Okay.
They're the same picture.
And then again, we have that nested hierarchy problem with functional versus non-functional DNA, but we already talked about that. Now, there are many ways to actually compare genomes. There are plenty of different tools, both downloadable and web browser based, out there if you want to try some of this stuff for yourself. But Tomkins, in this 2011 paper, uses a tool called BLAST. BLAST stands for Basic Local Alignment Search Tool and is used to find regions of similarity in genetic sequences. A sequence is just a string of base pairs, adenine, thymine, cytosine, and guanine for DNA, which is what we're concerned with for today. These are abbreviated as A's, T's, C's, and G's. BLAST works in a pretty intuitive fashion, using a heuristic algorithm to match queries to a known database. So, if I'm comparing a sequence in human chromosome 1, my query, to chimp chromosome 1, my database, BLAST will break my query into words. These words are smaller pieces of my query that serve to act as minimum matches before BLAST tries to align the full query to chimp chromosome 1's sequence. The whole database will be searched, and in the end, BLAST will spit out a list of the closest comparisons ranked by similarity. By the nature of this comparison, extremely short sequences will return many more identical matches that are ultimately kind of uninformative. There are probably untold numbers of ATA strings in the human genome matching to the chimp genome, for instance. But longer sequences aren't exactly perfect either. If we have a sequence of 100 base pairs with an insertion at base pair 50, should BLAST say that these two sequences are 99% similar or 50% similar? This is why BLAST has additional parameters that can allow it to ignore small differences and continue running comparisons if the operator desires. One such example is the gapped versus ungapped parameter, which not surprisingly controls whether gaps are allowed in the alignment. Gapped alignments can take insertions and deletions into account, while ungapped alignments cannot, but are much faster for it. Each has its strength. However, gapped is utilized when we're comparing two different species, as well as when we're comparing genes that are located in different portions of the genome. This goes for dogs versus wolves, and it goes for humans versus chimps as well. Both of these comparisons would utilize the gapped parameter. Ungapped, on the other hand, is great for comparing highly similar sequences that are also found within two members of the same species. The gapped versus ungapped distinction is a very important one with regard to BLAST because it can have very severe consequences if you end up using the wrong parameter for a certain analysis. Let me show you what I mean. We're going to be using an example from a paper that was written by a friend of the channel who, for the time being, will remain nameless, but I want to show what their paper looks like because it's going to come up again later. The ungapped parameter determines whether to account for small indels in the comparison. Indel is a portmanteau of the words insertion and deletion, and it refers to insertion and deletion events that can occur in the genome. Insertions refers to when one or more base pairs end up inserted in a place where they weren't previously, and deletion is the opposite. One or more base pairs ends up deleted from where they should be. Suppose we have a nucleotide sequence of 13 base pairs. If the ungapped parameter is used and there is a putative single nucleotide insertion in one of the sequences, then the BLAST algorithm cannot continue the alignment. Obviously, the first 6 nucleotides are identical in this example, but there seems to be an extra A in the query sequence which prevents the alignment from continuing any further. If the BLAST algorithm is unconstrained by the ungapped parameter, and we are using a gapped parameter, it is clever enough to insert a gap into the subject sequence, and that gap represents a putative insertion or deletion. So now we have the following alignment. The first example corresponds to the ungapped behavior and will report only 6 identical nucleotides in a query 13 nucleotides long for 46% similarity or identity. The second example allows for small insertions and deletions and will report that 12 out of the 13 nucleotides match, being 92% identical. And this is why we use the gapped parameter when comparing two species or even two individuals of the same species, depending on the locations we are comparing. Another important consideration when using BLAST is the type of genome that we're actually using. Genomes can be published in various ways, but FASTA files are common for BLAST and are easy enough to find. So the website you can see in the background is Ensemble, and Ensemble has loads of different published genomes and published chromosomes for different organisms. So if I click on the human here, I go to download FASTA, I click DNA, and what you can see is numerous different options for downloading the full genome versus downloading individual chromosomes. And what you'll see is that you've got mitochondrial DNA, the sex chromosomes, as well as 1 through 22, and you have these options here, just .dna, .rm, and .sm. So these stand for masking, like how this genome is masked. And masking simply refers to how the published genome handles highly repetitive elements. So in a genome that is masked, we're taking those highly repetitive elements and just reducing them to the capital letter N. You're basically blocking them out, and you're saying for our considerations today, we're not going to worry about these highly repetitive elements. Then you have soft masked, which takes those and they turn them into lowercase. So if I had a bunch of ATA repeats, it would turn them into lowercase ATAs. And then unmasked is exactly what it sounds like. It's a genome that has zero masking. So as you can imagine, the type of masking that you utilize is going to greatly impact the size of the file. So your unmasked and soft masked genomes and genetic material, like your chromosomes and stuff like that, are going to be significantly larger than masked. So for instance, your masked top level and primary assembly, so these are the full human genome, are 652 megs and 458 megs respectively. That's pretty big, but the top level and primary assembly for unmasked is 1 gig versus 840 megs. That's huge. And then if you go to the soft mask, which includes, I guess, additional information because we're dealing with lowercase, it's 1.1 gigs for the top level and 898 megs for the primary assembly, which these are just very large files. And when you're playing around in Ensemble and with BLAST, get ready to have like a lot of your space eaten up by genomes. So, when using BLAST to compare the genomes of 2 given species, how might we appropriately pick our genomes and set our parameters? Well, the masking is going to depend specifically on the type of analysis we're running, but we know for sure that we must use the gapped parameter. Otherwise, the entire analysis would be bogus, wouldn't it?
That's called foreshadowing.
There are loads of other parameters in BLAST, but generally speaking, especially with BLAST-N, you want to stick with the default parameters. They were set that way for a reason. Now that you know how BLAST works, let's get back to Jeffery Tomkins and his 2011 paper. Okay, so here it is on the Answers Research Journal. If we scroll down past his abstract, because we'll touch on his methods, what he did and what he found in a moment, you can see a section that's titled Creation Reviews and Analysis, or Creationist Reviews and Analysis. And it's in this section that we get our nice little dunk on Todd Wood, especially down here at the bottom, where he discusses more recently, Wood presented a human-chimp genome-wide comparison paper at the 2011 Creation Biology annual meeting and published a brief abstract of the effort. Wood indicated that he used the BLAST-N algorithm to align in pairwise fashion 40,000 random chimp genome sequences against the most recent version of the human genome. Then he goes, details about the algorithm parameters employed or how the data was returned and evaluated were lacking. He apparently used standard default parameters that would have incorporated sequence masking and the compiling of multiple hit data from single query sequences, chimp sequences, blah, 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 blah. So he goes on to talk and kind of speculate on whether or not he thought Wood used a specific subset of BLAST called megablast, and then he explains how he ran a much smaller test and got a lower similarity of 89% using the exact same BLAST parameters, which is kind of weird because, again, he says he doesn't know the BLAST parameters. But he goes on to say that an attempt was made to repeat a smaller subset of Wood's research using the standard default parameters for BLAST-N, word size 11, default gapping, and an e-value of 10. Now, the default gapping is gapped, right? So this is not an ungapped parameter, good stuff. But he says he only, achieved an 89% similarity. And he says that this was, published in Tomkins 2011 D. So if we scroll down to his references to Tomkins 2011 D, you can't access it. Evaluating the human chimp DNA myth, new research and data. And if you go and search this, it just takes you to an online publication with no real details as to what he actually did and how he performed his study. So I find that curious, but I think I know actually how he got that 89%, and I'm going to talk about that a little bit later, but let's move on for the time being. His next section after creationist reviews and analysis is a section that is, to me, humorously titled Genome Comparison, Philosophy and Approach. And after this section, we have the materials and methods, which is down here. Now, for those of you who might not know, when you publish something in the literature, materials and methods are where you say, here's what I did and here's how I did it. Curiously, there's a little bit of that hidden away in this section titled Genome Comparison, Philosophy and Approach. It is cast aside, but it cannot hide from us. Hidden away in this section, we have a quote down here that says, while a majority of the genome is now known to be widely functional, which of course we know is nonsense, but of course that citation is Wells, 2011. This is Jonathan Wells's book. It's called Icons of Evolution, Science or Myth. So we've got a nice unbiased scientist here who's definitely not also employed by ICR or one of its many sort of sister organizations. But this section is sort of Tomkins trying to justify the methods that he then turns around and uses. He tells us that he's going to be using unmasked genomes. That's fine, although it did make it a pain in the butt for me to replicate. And he talks about all these grand and multiple tests that he's running with different combinations of word size being 7, 11, and 15. 11 is the default, and e-value parameters, and all sorts of cool stuff like that. He's really letting us in on his thought process here. And then stashed away in what is the second to last paragraph, we get sort of the punchline. Given that the genome-wide analysis required a large amount of cumulative and comparative data, only the top alignment for each database hit if it existed was returned. Gapping was disallowed for a variety of reasons.
You can't get away with that.
First, this guy in 1990 determined that the addition of gapping strategies for alignments designed to locate regions of local similarity using BLAST was negligible. Secondly, if an objective comparison among all queries negates the use of gapping with the algorithm. Finally, the top local pairwise alignments that were obtained involved a variety of very liberal to very stringent matching parameters for word size and e-value. None of this matters. None of this means anything. The analysis is kaput because of that ungapped parameter that he utilized. And it was not in the materials and methods section. It was found there, stashed down in the second to last paragraph of the philosophy of his approach. And it's interesting because, of course, he talks about gapping. So if you control F here for ungapped, you don't get anything. There's nothing returns because he never uses the phrase ungapped despite the fact that that's what the parameter is called. He just says gapping was disallowed, which to me is, it's a little bit sneaky.
That's suspicious. That's weird.
So the analysis is worthless because of that ungapped parameter and we can move on. You might be thinking to yourself, well, how do we know that it's worthless? And we'll get there. We're going to come back to the analysis that he ran in this 2011 study and that little short analysis that he claims that he ran earlier as well, because I have things to say about both, but it'll ruin the punchline early if we talk too much about it now. So let's just put a pin in this one and say, ungapped parameter, not going to work, and move on. I did find out that Jeffery Tomkins has worked with Nathaniel Jeanson in the past, though, so that's kind of funny. So I guess people didn't react enough to this piece, or maybe it was the fact that the bonobo genome was published in 2012 and showed that we are just as similar to them as we are to chimpanzees, being 96 to 98.8% similar genomically speaking. But Jeffery Tomkins decided to take another stab at the human-chimp genome similarity in 2013 with this infamous gem. Comprehensive analysis of chimpanzee and human chromosomes reveal average DNA similarity of 70%. This one is just, and I can't wait to tell you why. The methods are in the right place this time, and he uses the published chimpanzee genome, evidently a masked version since he brings up having to remove the ends. And this chimpanzee reference genome was then compared to the human reference genome by slicing up the chimpanzee material into 100 to 650 base pair sections, depending on the chromosome in question. And the parameters utilized an ungapped comparison again.
Are you serious?
So the study is worthless, but it's actually funnier than that, because if you saw that 70%, you might be thinking to yourself, well, that's weird because he did ungapped earlier and he got 80 to 89% or 84 to 89%. Why so much lower now? And the reason it turns out is because he was using a bugged version of BLAST. The version of the tool he was actually using was bugged. And this was discovered by a one Glenn Williamson, also known as Ruhif online, who is a computer programmer. He's also the one that wrote this nice little paper, the excerpt from which we pulled from earlier. And if we scroll to the top, it's called Dr. Tomkins Falls Victim to Software Bug in Chimpanzee Comparison. So Glenn basically saw Tomkins' 70% number and he was like, this is stupid. Too stupid. There must be an additional flaw in the methodology, and he sussed out what it was. Now, if you're a young Earth creationist out there, you might be doing the usual little jig and saying, well, if Glenn Williamson's analysis was so good and Jeffery Tomkins was so wrong, why didn't Glenn publish his criticisms of Jeffery Tomkins in the Answers Research Journal itself? And to that I say, dear viewer, he did. Or at least he tried. Glenn Williamson submitted that exact manuscript we were looking at to the Answers Research Journal, remember, a young Earth creationist journal, and didn't hear anything for a hot minute. So Glenn reached out to Andrew Snelling, one of the main guys working at the ARJ. Now, Andrew Snelling is another young Earth creationist, obviously. He's a geologist. And this is what he said to Glenn on the status of his submitted paper with regard to the bug in BLAST. Hi, Glenn. Good day. I'm getting back to you with an update on where things are at. Jeff Tomkins and Nathaniel Jeanson have given me a report on the analysis of your paper. They say that the main issue with Glenn's paper is that it is claimed that there is a fault in BLAST N under certain conditions which don't apply to parameters Jeff used that no one has proven one way or another. They complain about Glenn's specificity for a moment before saying they conclude that Williamson's apparent lack of biological training, lack of familiarity with the biological literature, and his inability to analyze and report his own results, it is difficult to see the value in continuing to engage him, let alone give him the platform to air his uninformed and unhelpful views. Then Snelling comes back in with, there you have it. As editor, I accept the report. I agree you should take up the fault you claim to have found with the folks who wrote the code at NCBI. We will therefore not be publishing your paper. Thanks for trying and for being patient. We know you will not take this decision easily, but until such a time as you've contacted the NCBI folks and convinced them there is a problem in their code, which evolutionists also use, we will not consider your paper any further. Cheers, Andrew. Glenn responds, I'm actually not upset. I'm more energized than anything else. This was kind of the fight I was expecting. It all seemed to be going a little too easily up to now. While I go away and do some more work on this, I'd like you and Jeff to think about two things. The first thing that Glenn notes is that BLAST has been in use for 30 years, but there have been bugs in almost every version that are quickly caught and fixed, meaning double checking is at least worth consideration. Then Glenn says, notice the one thing that Dr. Tomkins didn't do was the one thing he could do to dispel the entire paper, referring to Glenn's paper, run his experiment again, but use parameters that can identify the sequences that don't return hits and then blast them manually. It's quite telling that he hasn't done this. I imagine it's because he's terrified of it. I don't give up very easily. I'll be in contact soon. Cheers. Snelling responds, hi Glenn, I never expected you would give up. However, you are wrong in your assertions. Jeff has been and continues to do new runs to test and retest his work. He is still confident in the outcomes and he has had Nathaniel Jeanson looking over his shoulder. Furthermore, he has been in contact with the programmers at NCBI and he is fully aware of the code's history and use. Meanwhile, you should do some more homework yourself. Cheers for now, Andrew. The two go back and forth for a while about contacting NCBI before Snelling responds to Glenn and informs him that he has been in contact with Jeffery Tomkins. Tomkins, it seems, has come around to the idea that there may in fact be a problem with BLAST, but proposes, quote, my solution to the whole mess is to publish my own report describing the observed problems with the BLAST N algorithm and acknowledging Glenn in it, unquote. Then Snelling comes back in with, so rather than you, quote, shooting, unquote, at Jeff, you should be writing a paper to get published in a bioinformatics journal. Only then will you have established the bugs in the algorithm among these experts, will you be in a position to then establish what the consequences are. Meanwhile, Jeff has promised to publish the results of his own investigations, which you will definitely get to see in due course. This does not rule out a future exchange with Jeff should that be necessary. You have been persistent to be sure, but for now we will not be publishing your paper. Thanks for your patience. Cheers, Andrew. So Glenn accepts this and begins the long wait for Tomkins' investigation into the potentially bugged version of Blast to come out.
6 months later.
Happy 6-month anniversary, says Glenn. Should I still be expecting a response? In fact, it was a little over 6 months ago that I wrote, what he needs to do is rerun his original experiment. If need be, only for a single chromosome. 22 is the smallest, and it is fine for the demonstration. But in his output, he needs to be able to identify the query and the subject sequences using the outformat parameters that I've talked about previously. Once he has done that, it is a simple manner of finding the query sequences that did not find a match and showing that they do in fact have a match, but that there is a bug in the software. That would have taken him a day at most. I have to remind you that he rejected my paper on the 6th of November last year, and in 18 days I reran the entire experiment across all chromosomes, not just a single chromosome as I'm asking Jeff to do, rewrote large portions of the paper, and resubmitted. The fact that he has had a lot more than 6 months to do this simple experiment, I've been asking since last October, I'm fairly certain that he has done it already and has gotten a result above 95% similarity, but he is just hoping that I will go away. Cheers. Snelling responds a few days later, apologetic for the delay due to fieldwork, saying, "Hi Glenn, I have checked with Jeff on his progress on what is a far more comprehensive study than just the experiments you have suggested are all that are necessary. He assures me that his work is almost complete and that he only has to wait for the results of the last few runs before he is ready to report the outcomes. He has outlined to me what has been involved, and I am satisfied that explains why it has all taken so long. Thoroughness in covering all bases requires time, so be patient a little longer and you will have your technical reply from Jeff. He is not simply hoping any problem will go away, but he is doing his homework thoroughly. Andrew."
Several months later.
Hi Andrew, it has now been more than 8 months since Jeff last responded and coming up to a year since I submitted my paper. Your last message said that Jeff, quote, only has to wait for the results of the last few runs before he is ready to report the outcomes, unquote, and that was a little over 8 weeks ago. So where are we at? Is he ready to report something? Anything? Smiley face. Hi Glenn, sure, time flies, but I know Jeff is working on his response by thoroughly testing different versions of the algorithm, plus testing with other algorithms, all of which takes time. He will definitely have a lot to report. I saw him a few weeks ago and he was very busy working away at it, so please continue to be patient. Cheers, Andrew. I don't understand the point of testing all those other versions and even other algorithms. The only question he needs to answer are, quote, is there a bug in the version I used, and is that the reason I got 70%, unquote. He can answer both of these with yes, and he could have done that in a couple of days and should have done that 8 months ago. I think you need to have a very candid conversation with Jeff and ask those very questions. 1, is there a bug in the version you used? Clearly yes, or do you disagree? And 2, if you work around the bug, do you get a result of 96 to 97%? Clearly yes, or do you disagree? That's all you need to decide whether to accept or reject my paper. Nothing else is relevant. From the sounds of it, Jeff is writing another paper entirely, but that's got nothing to do with his response to my paper. I don't deserve to be kept in the dark for so long, so I'd appreciate some insight, even a half-written report, as to what he is doing and why. As things stand right now, it certainly won't look very impartial to an external observer. And the longer this goes on, the worse it's going to look when it eventually comes out. I know both AIG and ICR express a belief that secular journals are unwilling to consider creationist research, so I guess here is a chance for you to show that creationists can be the bigger man. You'll be applauded if you publish, you'll lose a lot of credibility if you don't. Thanks. Glenn, we are satisfied that Jeff is doing the necessary detailed research to respond to your accusations and also at the same time settle the central question of your assertions. It matters not how you think Jeff should handle his response. He needed to test different versions of the algorithm and talk to the software developers. Jeff has told me today he has completed all the necessary research and is now working on the response paper, which he will have to me soon. So you will get to see his response in due course when it's published and not before. Cheers, Andrew.
Eventually.
Hi Glenn, attached is Jeff's response paper, which was posted today. You get acknowledged. Cheers, Andrew. Obviously, I'll respond in full when I have a chance to read it properly. First, few comments. 1, did my paper pass peer review? If so, where was it published? 2, did Jeff's paper pass peer review? How did they review such a long and technical paper in such a short amount of time? Who reviewed it? You said on the 18th of August that he had finished his research and started on his response paper. So in 7 weeks, he has written the response paper, perhaps 4 weeks' work, and someone has peer reviewed it in 3 weeks? Wow, that's a quick turnaround. 3, Jeff is using ungapped to derive his new 88% figure. That's an error. How did that one pass peer review? 4. Completely bizarre that Jeff would list me as representing Tibra Capital when I don't ever recall mentioning it to him, and also given the fact I haven't worked there since 2009. That's all for now. Hi Glenn, I was courteous enough to send you his paper. I am under no obligation to answer any or all of your questions. Jeff has been working on this project for many months, including the preparation of the paper, but exactly how long it took him to prepare the paper I don't know because he works in Dallas at ICR. Yes, his paper was peer-reviewed over several weeks, rather critically I might add, including by an expert on the relevant software. Your paper did not pass peer review, so it was not published. You were acknowledged by Jeff though. I guess he chose your last affiliation that he knew of. Any errors you claim he made are just your claim. Cheers, Andrew. Hi, Andrew. True, no one is going to come and put you in jail for not answering any of my questions, but according to your own guidelines for authors, when you reject a paper, it looks like you need to supply the stated reasons for rejection. We were in an absurd situation last year where the author being critiqued was also the reviewer of my paper, so it's not exactly an impartial situation. Jeff's responses last year showed someone that is clearly out of his depth when it comes to the BLAST software, and it seems he hasn't taken anything on board because he is still using the ungapped parameter as if indels didn't exist. I have to give him some credit though, the level of obfuscation in his paper is extraordinary. Anyway, I'll be curious to see how this whole thing plays out. Cheers, Glenn Williamson. Glenn, since your paper was not accepted and logged into our submission and review system, I am under no obligation to supply you anything, but it was reviewed by several competent people. Andrew. I hope I don't need to point out that this is certified weenie behavior. Snelling is literally like, I'm not telling with regard to any of Glenn's questions, despite the fact that Glenn was the one who brought the error to Tomkins' attention, as Tomkins mentions in his paper. Who do you suppose peer-reviewed Glenn's paper, you guys? Who do you think it was? Who do you think was the best person to pick from the middling staff at the Answers Research Journal with actual PhDs? Who do you think they got to look at Glenn Williamson's paper? Do you think it was Tomkins? I think it was Tomkins. You'll notice too that whoever peer-reviewed Tomkins' work was an expert in the software, not actual comparative genomics. That person would have absolutely no idea whether or not gapped or ungapped should be used as a parameter. But I guess it was good that he didn't use another bugged version of the program. I guess that's an improvement, even though that was a monumental error in the first place. I can't believe he didn't catch it. Now, everybody makes mistakes, but if you're doing work that is supposed to be so groundbreaking that it overturns a paradigm that's been held for decades and is held by every comparative genomics researcher on the planet, don't you think you'd maybe check for bugs, maybe run the analysis a couple of times, or maybe compare it with a control? But the fact that he used a bugged version of BLAST was indeed very embarrassing, and Jeff couldn't have someone like Glenn Williamson, a secular scientist, blow him up like this. So he simply rejected Glenn Williamson's paper as the peer reviewer and then published on the error himself. Documented anomaly in recent versions of the BLAST-N algorithm and a complete reanalysis of chimpanzee and human genome-wide DNA similarity using NUCMER and LASTs. Oh, a documented anomaly, huh? By who, Jeff? Who documented the anomaly? Oh, a computer programmer of financial trading algorithms, eh? I guess we're lucky he cited Glenn at all. In this analysis, we see BLAST utilized alongside two other tools, LASTs and NUCMER. It ran a very similar analysis to the 2013 piece, but now the slices are standardized to 300 base pairs each. Coverage was good, with a maximum coverage of 3 million per chromosome, which is, it's ungapped again.
Look, Pim, I know it's our job to help this guy and everything, but I think this guy's a lost cause. He's obviously made up his mind. Why don't we just cut our losses and get out of here?
Jeff, what are you doing? Now, at this point, you may be wondering, what exactly is the point? I mean, let's say for a moment Tomkins is right. Let's say that humans and chimpanzees are only 89% similar genomically, or they are only 84%, or 80%, or 70%. Let's say that that is the number. What does it mean? Because without reference to other species comparison, this number means absolutely nothing. What if Tomkins were to use his methods and compare rats and mice, for example? Now, Tomkins is a young Earth creationist. He's collaborated with ICR and Answers in Genesis and CMI, all of these big young Earth creationist organizations. And for those of you who don't know, young Earth creationists and creationists in general, but typically the young Earthers, tend to believe that in the beginning, when God created all of the animals on the planet, he created them according to their kind, and that they are allowed to diversify and change a little bit, just not too much. So for example, there's a cat kind, and all cats are related to one another and can change within that group, and all dogs are related to one another and can change within that group. But they would, of course, not accept that humans and chimpanzees are a part of the same kind or a part of the same group. So what about something like rats and mice? What if Tomkins's methods showed that rats and mice are less similar, genomically speaking, than humans and chimps? Because Answers in Genesis lists rats and mice as a part of the same kind on their giant Noah's Ark boat replica in the middle of Kentucky, and I would suspect that Tomkins would agree that rats and mice are a part of the same created kind. So what would happen? If rats and mice are less similar than humans and chimps, his argument that his reduced number for human-chimp similarity negates common ancestry between the two organisms falls apart, doesn't it? And seriously, isn't it so strange that he doesn't ever compare anything else? I mean, he's been obsessed with this particular number for decades, but he's only ever compared one human and one chimp. He's not even comparing chimps to chimps or humans to humans, just human versus chimp. And that's it. Nothing else for reference. And you know, isn't that strange? Isn't that suspicious? So I thought, why not compare more species? Why not just compare as many as we can and see how Tomkins's methods hash out with those things that creationists would consider to be related organisms. Now, like, I'm here telling you running an ungapped analysis is entirely inappropriate, completely unworthy of time, and really just a broken way of running a comparison. But let's jump into a fantasy realm of gingerbread men and unicorns and trickle-down economics for a moment, and let's just accept Tomkins's methods and, you know, do what he wasn't brave enough to do. Let's expand the analysis. So one more time for the uninitiated, there is a reason as to why this is relevant for creationists. They, and specifically young earthers, believe the earth was created by God some 6,000 years ago and that Noah's flood was a legitimate worldwide event that is responsible for the entirety of the geologic column. Answers in Genesis and the Institute for Creation Research, thus Tomkins, believe that all modern animals descend from the archetypal species that Noah took with him on that big boat. Creationists call these groups kinds, and it roughly translates to the family level in modern taxonomic terms. So Felidae, the cat kind, has a progenitor cat pair on the ark that then diversified into all felids we have today, as well as all fossil felids in between now and the start of the Cenozoic in just 4,400 years. If that sounds like evolution, but just on fast forward, that's because it is, and they just don't like to call it that. Functionally, there is no difference. Of course, this creates a problem, right? Modern lions and modern house cats are about 95% similar, and young Earth creationists consider them to be the same kind. Yet this is below 98.8%, isn't it? Despite using the exact same methods that give us the human-chimp similarity. This is why Tomkins needs the number to be lower, and I, as well as others, suspect it's also why we don't get any other comparisons. So I did the comparisons with a ton of help from Glenn Williamson himself, as well as from my husband, who's also a computer programmer, and we devised an excellent system to do these comparisons, and we ran quite a few of them. For the sake of posterity, let's go ahead and look at Tomkins's methods one more time, just so we know that we're using the same things, even though I've double, triple, quadruple checked this. If you go past his introduction down to the materials and methods, you can find out exactly what he did. He talks about here, plotting the data for figures was performed in R, and the BLAST-N parameters utilized were as follows. E-value 10, word size 11, max target sequence 1, dust, no soft masking, false, ungapped, and number of threads 6. So here's my configuration spreadsheet in Excel, and you can see there's a lot of methods here. I tried a lot of stuff out, but here is Tomkins 2013. It's the same as the 2015 method, so that's what I called it, and it is exactly the same as what we just read in his paper. We have e-value 10, word size 11, max target sequence 1, dust no, soft masking false, and ungapped as our parameters. This is what's going to be fed into BLAST as the parameters to be utilized when I click Tomkins 2013. And the method that I'm using for good, for our conventional science method, is this one here titled good max target sequence right there. Those are mostly just default parameters, but that's going to give us what an approximation of what conventional methods would get. Our methods were identical to Tomkins's methods. That was kind of the entire point. So what we did is we had our query organism and our database organism for each of our two comparisons. So let's say we were comparing a dog to a wolf. The dog is our query organism and the wolf is our database organism. One chromosome was compared at a time instead of doing obviously a full genome comparison. The end result was a full genome comparison, but we did chromosome 1, then chromosome 2, then chromosome 3, etc., etc. So in the case of our dog and our wolf, for chromosome 1, from the dog, we selected randomly 300 base pairs 1,000 times. So we got a full coverage on chromosome 1 and on every subsequent chromosome of 300,000 base pairs. Genomes are really big, but the sampling is random, and Tomkins actually showed in the paper we just went over, this 2015 paper, that there's really only about a 1% difference in, 1,000 versus 10,000 versus 100,000. So I stuck with what was manageable for my actual computer, which was a total of 300,000 base pairs per chromosome. BLAST then spits out a CSV for our results and then also places the percent similarity into one big CSV file so we can compare all of our organisms with a given range. And the cool thing about that is we also have a weighted and an unweighted score, which is going to be important for later. I'd like to take a minute to note here that the way we're running these comparative genomics is not ideal. This is not how you should run them, obviously, because we're using Tomkins's methods. Taking 1,300 base pair sequences is just not how this is done. I also would have liked to cover more of each chromosome than just 300,000 base pairs, but again, this is a really heavy-duty run for a computer to make. So what I will say is that if Tomkins thinks that my coverage, that my number of base pairs is not enough, he's got a great computer. He should just run my exact same analyses, but using his big fancy nice computer, and let's see the results that he gets. Alternatively, if I have to, I will pay for some kind of cloud service to make my point. There are no links that I will not go to ensure that Tomkins is sufficiently busted on this topic. So first things first, we repeated the chimpanzee to human comparison. We compared the most up-to-date version of the chimpanzee genome, which was Pantro 6 and was assembled without a human reference, versus the most recent human genome. Both versions were unmasked. Running the comparison using conventional means, we got a range of 97.88% to 98.45%, exactly in line with typical numbers seen for these two organisms. Tomkins's method yielded a range of 82.94% to 85.84%. The reason for the discrepancy in Tomkins's numbers and my numbers for his methods on that run, I think had something to do with the fact that I used the most recent version of the chimpanzee genome, Pantro 6, while in that run I believe he was using Pantro 5 or perhaps even Pantro 4. Next up was the comparison of the human to the bonobo. In the human bonobo comparison, conventional means yielded a range of 97.96% to 98.63%, again in line with conventional numbers. The Tomkins range was 84.66% to 85.67%. This wasn't that surprising to me either, and it was the second run that we did. I thought to myself, well, it only makes sense. Chimpanzees and bonobos are very, very closely related, as close as humans and Neanderthals or dogs to wolves, and so it would be only natural that Tomkins's methods would yield a similar distance from humans to bonobos as it did for humans to chimps. After all, Tomkins would consider chimpanzees and bonobos the same kind. So what about comparing chimpanzees and bonobos? What's their percent similarity? Next on the docket was the bonobo versus the chimpanzee. For this chimpanzee, we utilized Pantro 3 instead of Pantro 6. We used Pantro 3 instead of Pantro 6 for this particular comparison, just so Tomkins wouldn't accuse us of comparing apples to oranges. Using Pantro 6, he might say, is comparing a much more apish genome to the humanized bonobo genome. So instead, we compared two things that Tomkins would perhaps disapprove of, but should be the most similar. The range by conventional means was 99.21% to 99.5%, exactly in line with what we would expect for two highly similar animals. The Tomkins range was 84.48% to 85.98%. That's weird. That's right in the same range as the human-chimp similarity. I thought these things were supposed to be the same kind. Next, we compared the lion and the lynx. Conventional means yielded a range of 96.68% to 97.29%, and the Tomkins method yielded a range of 85.46% to 86.46%. Well, now wait a second. Lynx and lions are supposed to be the same kind as well, both in the Felidae kind. The lion versus the domestic cat yielded similar ranges, with conventional work giving 96.52% to 97.12%, and the Tomkins range being 87.66% to 89.41%. Well, okay, maybe Tomkins is just onto something really revolutionary here, right? Maybe he's actually found out that kinds are just a little bit more discriminatory than people had previously thought, and that, you have to be a lot more closely related in order for it to show up using his methods, with the exclusion of humans, of course, because they're different, they don't count. So maybe we should compare things that are really similar, that he would definitely accept as parts of the same kind. What about breeds of cow? Next, we compared two bovid hybrids. Bos taurus, or sometimes called Bos taurus taurus, is kind of like your classic western group of cows, whereas Bos indicus, sometimes called Bos taurus indicus, is your eastern version of cows that tends to be found in Southeast Asia, portions of East Africa, and India. Bos indicus versus Bos taurus conventional range was 99.19% to 99.65%. The Tomkins range was 84.65% to 85.43%. That's not right. That doesn't seem right. Is every breed of cow a different kind, Jeff? Well, hold on. What about people groups, huh? Answers in Genesis is always toting the evolution is bad and racist, but creationism is not bad and not racist. So what would happen if we ran Tomkins's methods on two human populations? What would their similarities or differences show up to be? Unmasked genomes were found for a member of the Han Chinese population and the Japanese population. Conventional range was 98.61% to 99.89%, and the Tomkins range was 79.66% to 87.65%.
That sucks. That's
not good, Jeffrey Tomkins. That's not good. I think maybe your methods don't work. This is the one that tipped me off, pushed me over the boiling point as to, they definitely don't work. They don't even approximate actual values. They're not even scaled downward. That ungapped parameter actually makes more closely related things appear more distant than less closely related things. Because, you guys, humans are ridiculously similar to one another. Ridiculously similar. Our genetic diversity is not very high. It's to the degree that, the two most disparate humans on the planet are still going to be more similar than any two randomly selected chimpanzees. But I really wanted to put the final nail in the coffin. So when I saw this number, I thought to myself, well, if two human populations aren't going to show up as similar to one another or nearly identical to one another, what would happen if I compared a human to a human, the identical two reference genomes, one reference genome to itself? And at this point, I'd wasted well over a month of time doing all of these comparisons, because I also included his 2018 methods, which we'll get to in a moment. I was running all of these comparisons. It was taking forever. It was like I was maybe getting through a genome a day, but then I had to run it twice, or 3 times, for all 3 forms of methods, the good, 2013, and 2018. So I was pretty exhausted. So I was like, okay, I'm going to run one chromosome, and I'm only going to run 100 sequences. That's it. First, I tested it with the good method. I used chromosome 21 because it's the smallest chromosome, and I ran chromosome 21 against itself using conventional means, and of course, as I should have, I got a 100% similarity. Then I ran the same thing with Tomkins's method, and here's what I got. 83.83% similar to itself. You are done, Tomkins. This method, it's through. It's finished. Throw the towel in. Your method sucks. Oh, and by the way, this was the same issue back with the 2011 paper from earlier. Dozens and dozens of hours wasted just to show that your method is bogus. And this is something that you figured out too, didn't you, Jeff? Because these are all the papers up to 2015, 2011, 2013, and 2015, all the same methods. But Tomkins doesn't quit publishing on the subject at 2015. He continues with different methods. Good, you might be thinking. Great. Jeffery Tomkins has switched to a more reasonable methodology, and now all is right in the world. You know where you are, right? After 2015, he publishes in 2016 an article titled Analysis of 101 Chimpanzee Trace Read Datasets, Assessment of Their Overall Similarity to Human and Possible Contamination with Human DNA. So here we are with our little 2016 paper. Jeffery Tomkins is going to be using trace reads this time. These are like longer sequences, not our little 300 base pair segments. However, they do average 704 base pairs, and he's comparing them to the human genome. And let's take a little peep at our methodology as we scoot on down. So we have our abstract. He actually doesn't waste a ton of time in his introduction this time. We get right into the materials and methods. So moving down to our BLAST parameters, we can see that they are here. So the following parameters: eValue 1, word size 11, there's his out format, and then he says max target sequence 1, max HSPS 1, does no soft masking false, percent identity 50. That's a little weird. Gap open 3, gap extend 3, number of threads 10. It's gapped. Oh my god. The analysis is gapped. Holy crap. We did it, boys. We finally did it. We ran something with a decent, not perfect, but decent methodology, at least compared to the nonsense we were using before, learning from our mistakes. Oh my god. This is a monumental win for young Earth creationists everywhere. We have seen here concrete evidence that young Earth creationists can actually change when faced with a mistake. Although, admittedly, it's not like Tomkins admitted that there was a mistake previously. He just kind of subtly changed around the methods and hoped that no one would notice. But I noticed, Jeff. So with these better methods, what does he actually get? Well, now this is strange. It may be that greater precautions towards human DNA contamination were taken in the later processing, producing less contamination. If the data from these seemingly less contaminated sets are considered, the chimpanzee genome is no more than 85% similar to human. If all the data sets are taken together despite apparent human DNA contamination, then the chimpanzee genome is no more than about 90% similar to a human. So he's kind of pushing for that 85% number, as I'm sure you can tell. And if you go and read this entire thing, the whole point of the paper is that he's like, the current chimpanzee assembly is contaminated with human DNA. And as I mentioned earlier, like, conventional science has taken notice of potential issues with the assemblies of other mammal genomes outside of the human. And since then, because remember, this is in 2016, we got an assembly, specifically the chimpanzee genome, that was used without reference to the human, that Tomkins later has a paper on, we'll touch on that next, that isn't contaminated with human DNA. Now, I'm not saying the earlier ones were necessarily. I'm saying Tomkins says it's not contaminated with human DNA. So we have his seal of approval, which is really all that matters when you think about it. Now, he's still getting this 85% number, right? Still in the 80s, even though he's like, okay, maybe it's 90%, but we're going to go with 85, excuse me. So, what's up with that? Perhaps we should introduce some controls, some references, and run this comparison with another pair of species just like we did last time because it went so well then. Whilst I was gearing up to make this comparison, I found that someone else already had. Joshua Swamidass. Joshua Swamidass is a religious scientist who accepts evolution and the age of the earth, and published a write-up on his forum, Peaceful Science, titled Mind the Controls, about this very topic. And he's been on this channel before. He's a friend of the channel. He notes that using Tomkins' methods in his 2016 piece does in fact yield an 85% similarity between humans and chimps, and that he got the same results when using this, at the time, newly published raw data. Swamidass thought to test the veracity of these results by introducing controls. You'll notice earlier that in the myriad of different comparisons that I ran myself, I didn't include rats and mice, and that's because I was saving it for this portion of the video since Dr. Swamidass has already done the work. Swamidass downloaded the same contiguous sequences that Tomkins utilized and compared the chimpanzee to the chimpanzee and got an 87% similarity. Then he compared humans and humans and got an 89% similarity. Then humans and chimps, as opposed to the other way around, and got 87% similarity. Swamidass then decided to compare rats and mice. Mice and rats are typically thought to be around 82% similar by conventional means, compared to the 98.8% in humans and chimps. So Swamidass simply ran the comparison using Tomkins' methods and found that it yields a 70% similarity between rats and mice. At least in this case, since Tomkins was utilizing the gapped parameter, the differences do scale. They're not exactly pure nonsense like with the ungapped parameter. For instance, chimpanzees compared with chimpanzees are more similar than humans versus chimps, which are more similar than rats versus mice, even though the actual number itself is considerably off when compared with conventional means. Now, Tomkins is welcome to claim that his results are the accurate results as compared to the dozens and dozens and dozens of conventional studies over the decades, but this would be a tacit admission that his methods show humans and chimps are both separate kinds as well as rats and mice, for a total of 4 kinds between the 4 organisms. Swamidass suggested that the errors are actually methodological in nature, but that the controls would have at least brought to Tomkins' attention that something was amiss within his methodology. But remember, Tomkins doesn't want to utilize the controls. He wants to introduce the human-chimp value in isolation, in a form that feels most controversial and compelling to young Earth creationists. So what I want you to take a moment and notice here is just how weaselly all of this seems. Now, it's possible, it is truly possible that Tomkins is genuinely discovering all these different methodologies organically, exploring them as a good scientist would. But I don't buy that for a second. I think that he's specifically trying to minimize the human-chimp genomic similarity and that he is willing to try absolutely any method to get the job done. Unfortunately, people keep testing his methods, exploring them, peer-reviewing them, if you will, and finding out that they suck, which forces him to pivot. It all must be very stressful for him. Now, one thing I will point out as a quick aside is the role that Richard Bugs plays in all of this. Bugs is a geneticist, and a conventional one by all accounts. He caused a bit of a stir in the 2010s in some circles because he actually felt that 84% similarity between humans and chimps was appropriate. He got this number by maximizing differences as well, counting each base difference as a difference in and of itself, and counting the unsequenced regions at the time in the dissimilar category. Of course, Bugs was okay with counting differences like this across the animal kingdom. All gaps would widen, and humans and chimps would still be one another's closest living relatives. This didn't stop countless creationists from name-dropping him, nor did it stop Tomkins from specifically claiming that their work corroborated one another's. Now, we could go into the details as to why some people did find Richard Buggs's method of counting up differences to be appropriate, but it's basically akin to debating whether or not you should count a page duplication in a book as a duplication of a page, or every letter as a singular difference when accounting the total similarity between the two books. It ultimately doesn't even matter though, because in 2020, Richard Buggs published a new method of comparing genomes and found humans and chimps to be about 96% similar. I guess he finally came around. Or did the evil evolutionist cabal beat him into submission? Soon, the evil League of Evolution Acceptors will reach every scientist and force them all to believe in evolution. Wait, they already do? Jeffery Tomkins fans are real quiet about this one, but we still have one last paper to cover, and this is his most recent ARJ publication on the topic in 2018, titled Comparison of 18,000 de novo assembled chimpanzee contigs to the human genome yields average blast and alignment identities of 84%. And this is his last chance for now, at least, because this is the most recent methodological piece on the subject. This is his shot to convince us, to convince me, that he has something going for him. Now, given this was in 2018, and it's 2023, and scientists still hold that humans are 96 to 98.8% similar to chimpanzees, well, that should give you a clue. This time we finally have what Jeff's been waiting for, a chimpanzee genome that is not used a human reference, as we've talked about several times before. One of the chief problems with all versions of the chimpanzee genome prior to Pantro 6, this is the genome that we utilize in our analyses, is that they were not constructed through the use of an accurate, integrated physical genetic map and its corresponding genomic resources in a systematic fashion like the human genome and other key model animal genomes. Instead, short DNA sequences generated by the sequencing machinery, known as trace reads, largely produced a whole genome through a shotgun approach that were assembled onto the human genome using it as a reference scaffold. But not anymore. This time we're using Pantro 6. And as he says here, another bonus, this one doesn't seem to be having the same issue as the previous versions with human contamination. We've got a fix for that, a fix for the human scaffold, and this is going to be the real version. This time, for real. We see an acknowledgement of Richard Buggs, who we already covered down here, and he talks about the recent improvements with Pantro 5 and Pantro 6, and that he's going to perform the sort of objective reassessment of the human-chimp genomic similarity himself. Now, I can respect that. I can respect taking matters into one's own hands and doing an overly gratuitous analysis to make a point. Methods, one last time. Let's take a look at our parameters. E-value 0.1, word size 11. There's our out format. Max target sequence 1, max HSPS 1, dust no, soft masking false, percent identity 50. Again, that's kind of sketch, but it doesn't really matter. Gap open 3, gap extend 3, number of threads 10. It's gapped again. Yay, yay, yay. That's fantastic. We're glad to see that. All is not well in the kingdom, though, and we'll get to that in a moment, because Tomkins actually publishes his results on GitHub in a CSV file. We will come back to that. First, let's look at what he sort of proposes his results are here in the paper. So he talks about the sort of lengths of many of the sequences, how lots of the contiguous sequences were really short. This is the portion that we really care about here. Comparison to human. The main finding of the significance to the issue of alleged common ancestry between humans and chimpanzees is the fact that the average alignment identity was only 84%. See Table 1. Despite the gap extension parameters being quite liberal, the average mean alignment length was only 10,509 bases as a result of the algorithm hitting a gap that was too large for it to traverse. Thus, only about 1/3 of each chimpanzee contig on average could be aligned to the human genome as the best hit. These data obviously exclude the less alignable portions of the contigs as well as those regions that would be completely unalignable. Thus, the overall identity of the chimpanzee genome compared to the human would actually be significantly lower than 84%. So that's where that 84% number comes from. And as you know, we went through his methods and it was fine, right? We're using gapped as a parameter. There are a couple of things that are kind of weird, but by and large, it's not a huge issue. And it doesn't have the same problem that the previous study that we looked at that Joshua Swamidas checked with his controls, which is that they're kind of new raw reads. These have had a little bit more time to be peer-reviewed and to be refined. So what then is the problem? Well, before we dig into that, let's kind of go down here towards his conclusion, because I quite like what he says down here. I think it's kind of funny. So he says, a glaring overall 20% DNA similarity difference between the human and chimpanzee genome is an evolutionary discrepancy that cannot be dismissed. And the reason it's now become 80% instead of 84 is because he cites Richard Buggs up here, who talks about 4.06 having no alignment to the chimp assembly. So he's just adding that in and reducing it down further. But we already talked about Richard Buggs. So this extreme level of genetic discontinuity raises serious issues for the evolutionary myth that humans and chimpanzees share a common ancestor not more than about 3 to 6 million years ago, which largely depends on the 98 to 99% DNA similarity to seem theoretically possible. This sentence is an absolute mess. First of all, the aggression. This is something that I didn't see in the previous papers, and maybe I just didn't catch it. But here, this is gung-ho. He is mad here, and he thinks he's really, driven a stake in, or does he? Because again, we'll talk about how much does Tomkins know about his own work? How much does he know with regard to its robusticity? But who has ever said this? Who has ever said that the common ancestry between humans and chimps depends on 98 to 99% DNA similarity? No one has ever said that, ever. The point is that humans and chimpanzees are one another's closest living relatives, right? It's the fact that it's reciprocal. Chimps are our closest living relatives, and the reverse is also true. The fact that the similarity is very high is helpful in making the case, but it doesn't have to be 98%, it doesn't have to be 96%, it doesn't even have to be 90%. The point still stands, and again, in reference to other organisms, humans and chimps are closer than many, many pairs that young Earth creationists like Jeffery Tomkins would consider a part of the same created group, like cats and lions, or like Asian and African elephants, or like rats and mice. But I digress. Again, this is why he doesn't ever compare anything else other than humans and chimps. The uniqueness of mankind, as stated in Genesis, so God created man in his own image. In the image of God, he created him. Male and female, he created them. Genesis 1:27, New King James Version, is now soundly confirmed by the scientific data. I think he dislocated his shoulders, his highly mobile ape-like shoulders, with a reach like this. Like, if we assume for a moment that his numbers are correct and humans and chimps are only 80% similar to one another, this would be like a Muslim individual pointing out that one sentence is different in the current version of the King James Bible and a version from 100 years ago, and that makes Islam true and Christianity false. And that's if his numbers were right, which they're not. He's got to grapple with the overwhelming preponderance of everything else, but also his numbers are not correct. And I'm going to prove that to you now by looking at his data. So let's do so together. If you scroll back up to that sort of materials and methods section here, you can click on the GitHub link and it's going to jump scare you with this picture of Jeffery Tomkins that he uploaded to his GitHub account. You're going to click on chimp contigs here, and it's going to take you to this little upload repository. And you're going to want to click on all 18K chimp contigs on homo.csv. Now, you're going to need to download this CSV, so you're going to click on it. It's going to take you to, the raw data, and then you're going to save that link so that you can then open it within Excel, which is what we're going to do. So here's my Excel file. It's going to look different from yours because what you're going to want to do is take all of Tomkins's data, put it into a table, and give some headers that are going to match the data, his actual output. And you can find his output, again, back in his paper. So you have the sequence ID, that's the accession number, QStart, QN, the mismatch, the gap open, the p-ident, percent identity, n-ident, length, and qlen. So I've labeled those for you here just so we know what we're all talking about. So we're all on the same page. And what I've done is I've sorted by query length. So we've got our smallest query lengths at the top and the biggest ones at the bottom, which you can see rather, if we scroll down to the bottom of our roughly 18,000 sequences. So here we go. We end with 17,991, and that's our largest query length, or qlen. So let's find out how Tomkins got that 84%. But first, allow me to tell you a little anecdote. I teach at a university. I teach biological anthropology lab. And what that means is that I have to deal with a lot of students. And what I've come to learn is that some students are better versed than others when it comes to understanding how math works. And what I mean by that is that sometimes students will come to me and they'll say, hey, I thought I had a much higher grade in my class than I actually have. And I'll say, well, how did you come up with this grade? And they'll walk me through it. And what they've done is they've taken all of the grades in their grade books, all their percentages for different grades, and they've averaged them to get a total percentage for their grade. But their mistake is they average tests that are like 100 points as being the same, as just averaging the same with like 5-point attendance percentages. So 5 out of 5, that's 100%. And they'll weight that the same as like a 60% out of 100 points for a test. And that, of course, erroneously leads them to come up with a grade that is higher than perhaps they thought, because they aren't weighting the actual assessments. And this always disappoints me, because I think to myself, this is stuff I learned in middle school. I'm sure many of you learned how to weight things in middle school as well. And I always am concerned when I see 18-year-olds and 19-year-olds making this same mistake. So imagine my surprise when I come to find out that that is what Jeffery Tomkins did. Looking at these numbers, again, our n-ident, this is the number of identical base pairs in a length. So 203 identical base pairs out of a 208 length gives us a 97% similarity between the query and the database, between the chimpanzee and the human. Again, below it, we see 309 out of 444. That gives us a 69%. And if we scroll all the way to the bottom, we can see that we have, out of our 18,000 or so contiguous sequences, we can see that we have 163,989 out of 167,095, which gives us a 98% similarity between those two sequences. So what Tomkins did is he just took the average of the percent identity column right here. Boom, there it is, 84.387%. He is weighing a 444 base pair sequence as identical to sequences that are over 150,000 base pairs long. He is making the mistake of a middle schooler. But here's the kicker with this. Let's do it the right way. So if we take the sum of our entire n-ident, and then we take the sum of our entire length, and we divide the first by the second, we get 96%. When we weight them, we get conventional numbers. Tomkins, you goofball. I suspect this is also what happened back when he initially replicated Todd Wood's work in 2011 with default parameters. Now, before you say to yourself, wow, gutsickgibbon, awesome sleuthing, what you need to know is that I didn't have to figure this out. This was another one where someone else beat me to it, and this time it was our old pal, Glenn Williamson, who actually sussed this mistake out years ago. And I want to share something very, very funny with you. In this video titled Creationist Peer Review is Utter Poo by Ruhif, Glenn Williamson, we see the exact same thing I just showed you, because I used this as my lattice to pull it up and walk you through the situation. Now, this is great. Ruhif's awesome. I think Glenn has done a great job with all of this stuff. But let's just scroll down to the comments section, because the first comment, as pinned by Ruhif, is by Jeffery Tomkins himself. What does he have to say? He says, Ruhif, aka Glenn Williamson, has put forth several deceptive arguments in this slanderous and crude video that do nothing to debunk my research when carefully considered. Oh, Jeffery, that sounds quite convincing. I'm preparing myself for what is to come. First, Glenn uses the absurd argument of taking the average fuel efficiency of 2 automobile trips, one short and one long, with a sample size of n equals 2, and then tries to compare this ridiculous example to my research where I calculated an average using a sample size of n equals 18,000. So I sort of took my own anecdotal version of what Ruhif did here, which is he used an example of fuel efficiency to show why you have to weight things. So he says, you take this long trip from Sydney to Melbourne and then a short trip from his house to the supermarket. How do you actually come up with your average fuel efficiency? And you have to actually weight it. You can't just take a rote average, right? Or a brute average, excuse me. So it doesn't matter what your sample size is, Jeff. You have to weight things no matter what. Like increasing the number doesn't change the requirements of having to weight things by their length. So he continues on and says, second, he calculates the average alignment identity by dividing the total number of nucleotide matches by the alignment length, giving 96%. No surprise here, because this is the standard average identity for regions that can be matched between the human and chimp using blast and gap extension, but does not include regions that are so dissimilar they cannot be matched by the algorithm, an important issue with Glenn conveniently never addresses. Fortunately, we addressed this in the video, and we talked about how Richard Buggs has dealt with this and how he's come up with a new way of actually aligning genomes and still comes up with 96%. We've also talked about how we've increased our actual coverage of the human genome and the chimpanzee genome, and the number has gone up of percentage similarity between the two organisms. Then he says, in fact, if we divide the total number of nucleotide matches by the total amount of sequences queried, we get about a 30% similarity, which is not an accurate estimate of similarity either. Yes, thank you, Jeff, for telling us another bad way you could run this. No one was suggesting that that's how it should be run. You're just saying, look, see, there's a worse way to do it. I didn't do it that way. He says, my method sought to get around these algorithm limitation issues, and it just so happens that my approach of determining an average DNA similarity, which is entirely reasonable, just to assure us, it is reasonable, matches the exact same human-chimp DNA identity of 84% achieved by University of London evolutionary geneticist Richard Buggs. He used BLAST-Z genome-Y alignment results from the UCSC genome browser website. And then you get excited because there's like 9 comments, but Jeff never comes back. So he bails, he dodges because Ruhif responds and says, let's discuss this one point at a time. LOL, off to a cracking start. I was actually getting a little bored with flat earthers, so welcome to my channel. Let's discuss this one point at a time. So he talks about the fuel efficiency thing. He says, my fuel efficiency example is to demonstrate why you should give each sample a relative weight, then apply it to however many samples you have, be it 2 or 18,000. A sample size of just 2 makes my point easy to understand. Of course it still applies to n equals 18,000. Yeah, duh, it doesn't matter. So of course, Jeffery Tomkins does not reply to this point, but I did think it was very funny that Jeff came storming the castle here to try and defend himself and made himself actually look worse, at least in my opinion. So the other day I was browsing Reddit, and there was actually a new Ask Reddit thread that I thought was kind of interesting. It was asking people their sort of anecdotal experiences with highly educated people with PhDs or otherwise higher education, who were really intelligent, but had like kind of really weird, bad, wrong opinions in other areas. And to me, this felt like divine revelation from the Lord Almighty himself, telling me that Tomkins has indeed blown it, due in part perhaps to the fact that he is a plant geneticist working with mammals. But also, you guys, like, it's really hard to get around the fact that he's got a PhD in genetics and doesn't know to weight sequences. That's alarming, isn't it? I think it's really telling that some creationist organizations have opted to move away from Tomkins and his work entirely. It seems like the old Earth creationists and the intelligent design advocates really don't buy it, as we can see in this article at Evolution News, which is an intelligent design think tank website called Human-Chimp Similarity. What is it and what does it mean? And if we scroll down, we can see several different numbers will pop up. We see the myth of 1%. This has popped up before, but this is basically just the original figure that was like, it's not 99% for the full genome, it's 96% for the full genome, which is true. They go down, continuing on to talk about Richard Buggs, talking about his original 2018 blog post, which I don't know if I told you this, but that's what Tomkins is citing when he's citing Richard Buggs, not a published paper. A blog post. When he actually did publish, again, it's 96%, as we saw with his previous publication on genomic comparisons in 2020. But they never really mentioned Tomkins. In fact, they don't mention Tomkins at all. We get a mention of his number, 84%, but there's nothing really else. In fact, you go down to the citations, if there are citations, oh, the citations are in text, you hover over them. There's no Tomkins. We can Control F, no Tomkins. Jeff is out. And of course, the only other example I can really think of within the YEC community would be like Todd Wood. He had never bought the number in the first place. I don't believe Kurt Wise does either. So Tomkins is shoehorned. He's got AIG and he's got ICR, and that's about it. So we've taken the time here to go through many of Tomkins's larger methodological works with regard to the topic of the human and chimpanzee genomic similarity. We've seen that about half of them are bogus because they use the ungapped parameter, something that does not work when you apply it to humans and humans. Comparing a genome to itself, you don't get 100% similarity. And we saw how when he switched up his methods, that didn't help things. Controls were needed in his 2016 paper, and when including them, it showed that work to be nonsense, and in his 2018 paper, he made a simple arithmetic mistake. He didn't weight his sequences. So there is not one piece of Jeffery Tomkins's work with regard to this subject that stands up to any kind of scrutiny at all. And not even other creationists are buying it at this point. It's just the loyalists that stand by Tomkins's side. So what do we do with this information, right? I mean, Tomkins has published in secular journals. He has a PhD, and his work in secular journals seems robust, at least as much as I can understand it. How does a guy like that, a first author on a dozen or so papers, manage to make such simple, basic, baby mistakes? Well, they don't. In fact, I am of the opinion, this is an opinion, that these are not mistakes at all, and that Jeffery Tomkins knows exactly what he's done here. It's not even so much the mistakes in isolation, it's the accumulation of the mistakes. It's how the methodology has warped and changed once confronted with peer review from secular scientists, and it kind of leads me to believe that Jeffery Tomkins is doing a little coal hop dance, trying to stay afloat with these nonsense numbers for as long as possible. I am of the opinion that he is being deceptive, and unfortunately this is an opinion that I find myself levying against more and more professional creationists the longer I do this job. To me, there's just no other explanation, especially having seen him directly respond to the weighted versus unweighted issue as posed by Glenn Williamson, a very basic error, and his response was basically, nuh-uh, it's not an error, I did that on purpose, and it was the right thing to do, but it's just brutally not. That leads me to my next question. How does an evangelical justify this? How would Tomkins justify this if this is indeed intentional and a sort of tactical series of mistakes? Well, I think that he must genuinely believe that he will be vindicated eventually. I think there's got to be some underlying hope that if he just holds the line now, eventually he'll be shown to be correct, because he thinks that he's genuinely interpreting God's word, like the God of the universe's word. So, of course, he must be proven to be correct eventually. And I guess to him, it's just acceptable to lie in the meantime if it means saving more souls. This is all speculation. Again, like, Tomkins might be an absolutely lovely guy who's just really bad at mammal genetics and phenomenal at plant genetics. Swamidass has attested that he's a good guy, but I've never met him. I've only seen his work. I've only seen a lot of his work. And so I have formed my own opinion, and you must form yours. So this was where the video was supposed to end. It was completed and put up on Patreon for everybody to see, and then Jeffery Tomkins decided to go on a sort of call-in interview style show, and it allowed for a Q&A. So I made myself present, and myself and others got to ask Jeff some questions in the side chat, and that has given me cause to think. And this isn't because Jeff has changed my mind on anything with regard to the science. No, he's given me cause to reconsider my assessment of him as a person. As you just saw, my opinion on Jeffery Tomkins has been, at least for the duration of studying for this video and preparing for this video and running experiments for this video, including reading all of Jeff's work related to this topic, has been that he is too educated to be making these kinds of mistakes. It can't be incompetence, so it must be deception. I realize that's a harsh dichotomy, but I really don't know what else it could be. If you have someone who is educated in a topic who's making mistakes, they're either making mistakes because it's a mistake, it's an accident, which is unlikely since he continues to make these same mistakes over and over and over again, even when they're pointed out to him, or the alternative is that they are intentionally doing what they're doing, meaning they are being deceptive. Those are really the only two options. It's incompetence or it's deception. And I don't really know what to do with Jeff. Let me explain why. Jeff's presentation effectively included everything we've gone over here, and so I'm going to skip to the Q&A, and I'm going to start with my first question so you can experience this interaction as I experienced it.
Sure.
Our first one comes from Gutsick Gibbon. That's her handle name. She says, "Are chimpanzees and bonobos different kinds?" Great question.
No, they're interfertile. They're chimps.
Okay.
My understanding is that bonobos and chimpanzees probably can hybridize. They are about as similar to one another as we are to Neanderthals, and we could hybridize with them. Of course, the evolution of reproductive isolation is messy, but I don't know of any actual examples of bonobo-chimpanzee hybrids, so we'll just accept that they can hybridize. That's fine. The really important part here is that Jeffrey Tomkins does think that chimpanzees and bonobos are the same kind of animal, which is incredibly problematic given they are about as similar to one another as humans are to chimps using Tomkins's method, so his methods don't work, or all three of us are the same kind, I suppose. Also, for those of you out there who might be curious, Jeffrey Tomkins also thinks that chimpanzees and bonobos are a different kind as compared to gorillas, which are both different kinds compared to orangutans, which that's pretty contra to like the Answers in Genesis typical spiel where they say there's one ape kind. So the people asking questions in the live chat for this show, which had about like 34 max people watching at any given time, consisted of me, Dan from Creation Myths, Joel Duff, a random guy named like Hermit Crab or something like that, and Standing for Truth. Like I said, Donnie is having a bad week.
This is from Standing for Truth. He says, "Have we derived a percentage of genetic similarity between humans using the same methodology used to get the 84% similarity between humans and chimpanzees? Would it be 99%? God bless."
Donnie is actually asking this question in part due to me because I brought up the discrepancy to him the last time we spoke on someone else's channel, and what I said to him was that Tomkins's methods are improperly scaled. If humans and chimps aren't 98.8, then the 99% between any two given humans would also widen. And this is because I was under the impression at the time that Tomkins's methods were at least internally consistent and were more similar to what Richard Buggs initially did. As we've seen in this video, that is not the case. Tomkins's methods just do not work up until 2015, and then after that, he just doesn't weight anything. But I was tickled to see Donnie ask this question.
Yeah, that's a really great question. And actually, I had a guy, he's a friend of mine. He's actually involved in the Human Genome Project. His specialty is retro elements and transposable elements. And I can't give his name because he's trying to lay low.
I guess the point here is that Jeffrey Tomkins has like a secret friend who worked on the Human Genome Project, and the implication, I guess, is that they were a creationist. We can just take him at face value at that. I don't really care. What he goes on to talk about, though, is structural variants. And Tomkins makes the point that his friend says that if you took the two most disparate human genomes with the most number of structural variant differences, that difference can make the genomes ultimately like around 4% different. So like he's basically saying that the two most distant humans could probably be 96% similar, and then he's like, so how are we supposed to believe that we're only 1% different from a chimpanzee? Like, not understanding that structurally variant areas aren't all in the functional regions of the genome, so really we should be comparing like the human maximum structural differences to the 96 number for human chimp comparison, including indels, because it's like part of what structural variants include, but also that some of those structural variants, in fact, a lot of them, are going to overlap with areas that are already different between the human and chimp. So if humans can be 4% different from one another, and I don't think they can, I'm not a geneticist, but I did a literature search for this and couldn't find anything, then the maximum difference between two humans is still going to be more similar than any given human and a chimpanzee.
But if you compare the structural variants between any two human genomes, they can be up to 4.5% different from each other. So if any two humans based on structural variance can, be up to 5% difference from each other, how are we only 1% different from a chimp? So, we have a lot to learn, I think, about genome structure and variation, and even in the human genome, where they're still trying to figure out all this structural variation that's present. So I think with this new DNA sequencing technology, the PacBio sequencing technology, and there's ion torrent and other chemistries out there as well. They're proprietary, that produce long reads. I think we're going to see a lot of really amazing, interesting things coming out of the Human Genome Project.
So the answer is no. We haven't run the same exact methods where we get an 84% for human and chimp onto humans to see if we get 99%. Or we hadn't until I did it. And using that method, using Jeffery Tomkins's method, the difference is like 79 to 87%. Unless he's talking about using the weighted version of his 2018 numbers, which would give a 99-ish% similarity for any two humans, and then a 96% similarity for human and chimp.
Another question from Creation Myths. Does a 1,000 base pair deletion present in one genome, but not the other, count as a single difference or 1,000 differences in your methodology?
I'm not sure how I would answer that. I mean, it's it's just 1,000 base difference. So yeah, I don't know.
This is a really good question and really incredibly important as to understanding how someone would get a percent similarity between any two given organisms. The example that I used earlier was between two books. So what Dan is asking is if we have two books, and in one book we have an entire page duplicated as compared to the other book. They're identical in every other way. Do we count the duplication of that page as a single duplication because one page was duplicated, it occurred in one event? Or do we take every single letter that's different between the two books as a difference in order to come up with a total percent difference?
I'm not sure how I would answer that.
You're not sure how to answer a question that is absolutely pivotal to coming up with the percent difference between two genomes. You're not sure?
I mean, it's it's just 1,000 base difference. So yeah, I don't know that I would put any label on that necessarily, other than it's just a difference. It's 1,000 base difference, hypothetically, if that's what we're looking at. Yeah.
What? He just, what is he saying here? He just said it's a difference. I would say it's a difference. I mean, it's 1,000 base pair difference. Hypothetical. Well, which one is it? Jeff?
Okay. This is
mean, my methodology is looking at the overall picture, not just trying to, kind of narrow it down to some, yeah. Anyways.
Okay.
I was stunned by this when I first saw it. I actually had my jaw on the floor. I can't believe it. He's just hand-waving away a massive stipulation as far as coming up with or declaring how you're coming up with your percent similarity. You absolutely have to be clear with how you are counting differences. Is an indel a difference, or is every portion of an indel a difference? You have to be specific. This is just proper methodology, but it's not even that. It's not even that he's not being clear. It sounds like he doesn't really know the difference. It sounds like he doesn't think that it matters. And this is one of the most important things to be clear on when you're comparing two organisms within comparative genomics. And this is supposed to be the guy that is overturning the paradigm here. And he just doesn't seem to know. This is what caused me to make an amendment to this video. I don't know about Jeffery Tomkins. Is he being deceptive, or is he kind of incompetent, at least when it comes to comparing mammal genomes? I don't know anymore.
This is from Gutsick Gibbon. Do you have any predictions on the similarity between other kinds you would accept as so? Cats, lions, dogs, wolves, rats, mice. Do you feel genetics is the way forward with kinds?
I've actually looked at that issue with a friend of mine who is a bioinformaticist. He worked in the biomedical field, and now he was working for big pharma doing bioinformatics. it's really difficult. It's like comparing apples and oranges.
So if Jeffrey Tomkins is correct, though, then it is abjectly the opposite of comparing apples and oranges. Comparing two things within a kind is like comparing apples and apples, and comparing apples to oranges should be reserved for comparing things from two different kinds. But I don't think he got the question, because he goes on to say this.
So if you were to look at, say, humans and rabbits or humans and rats or whatever, you've got different chromosome numbers, different chromosome structures, different gene neighborhood structures. So gene neighborhoods are very interesting. That's basically the content of genes within a large section of a chromosome. It's almost impossible, really, to compare, stuff that is so dissimilar.
But that's not how it should be if they're within the same kind, because Jeff is perfectly fine comparing humans to humans, which he thinks those are both within the same kind, and he's fine even comparing humans and chimps, which, according to him, are not. So why can't you compare organisms that are more distant? But again, that wasn't the question. The question is, does he have any predictions with regard to the percent similarity between two things that he thinks are within the same kind, like cats and lions, or rats and mice?
We did make an attempt at it, and we tried to create these coefficients of similarity statistically, but it was just too difficult to really get to the bottom of that.
They tried it, but it was too difficult. That's weird, because I tried it and it was super easy. It just took a really long time because your methods create enormous files. Now, in all seriousness, I think what's going on here is that wires are getting crossed. Jeff thought that the question was asking, how do you compare organisms with different chromosome numbers, which can be really difficult because of how genetic material gets switched around. But the question was, how do you compare organisms that are within the same kind that do have the same chromosome number, whose genomes are fully available on things like Ensemble? Now, to me, it seems pretty impossible that Jeffrey Tomkins found it to be very difficult to compare organisms with different chromosome numbers without first having attempted comparing organisms with the same chromosome number. So I am left to believe that he has, in fact, in my opinion, compared organisms that should be within the same kind that have the same chromosome number, and unfortunately did not get the answer that he wanted. I don't know that to be the case, but again, it sounds to me like he's at least worked with the genomes of other organisms here, and the fact that he's never published anything on their percent similarity using his methods is concerning.
Okay, this question is from Joel Duff. He asks, from a young Earth perspective, can we make a testable prediction about what the genetic similarity would be between a wolf and a gray fox, or a cheetah and a lion using your methodology?
That's an interesting question. I guess that would be a fun project to do that. That's interesting. Yeah. I don't know that we have really good quality genomes for these creatures. We definitely do for dogs and wolves. A lot of research has been done there in DNA sequencing. And with cats, I know that there's been some work done there as well. But yeah, that's interesting. That would be a fun project, but it would all be based on the overall quality of the genomes, how complete they were. But that's a great question.
I went ahead and compared the published dog to the published wolf, and I just did chromosome 1, I just did 1,000 sequences of 300 base pairs, and Tomkins's 2013 method has them being approximately 85% similar, weighted. Okay though, do you see how weird this entire interview is with these questions? Because the last question asked made me think that he was doing these comparative genomics between organisms with pretty different genomes to the extent that they have different chromosome numbers. In fact, he said he tried to do it, but then now he sounds like he's never even considered comparing organisms that are within the same kind that have the same size genome or similar size genome with at least the same number of chromosomes. That is very, very impeccably strange, isn't it? But at the same time, what do you do with that information? Like, is Tomkins being dishonest and he was being honest about the previous comparison and he actually has compared dogs and wolves, but he just hasn't published the results because it'll show that they, using his methods, are about as similar as humans and chimps are, proving that his methods don't work? Or is he kind of incompetent and genuinely hasn't considered comparing two other organisms that should be within the same kind using his methods? It just doesn't make any sense.
This is our final anonymous question, and then after that, we're going to close. So this is, here's the question. A well-known creation scientist, Dr. Marcus Ross, has stated in a recent interview on YouTube that your estimate of 80% or 84% chimp human DNA identity is inaccurate and should be closer to 94% because your analysis counted all differences equally, including duplications and insertions, and does not account for genome size differences. Is it true that if you account for these things, your estimate would be closer to 94%?
So just a quick note here, I'm like 99% sure that the anonymous question asker is just Donnie of Standing for Truth again. And the reason I say that is because I know Donnie was wanting to keep tabs on this thing. He wanted to make sure that it went well. It did not. And he had to skedaddle off to a debate, which is why he left like really early into this interview. I also happen to know that Donnie and Roop are friends and that they communicate frequently and collaborate on blog posts together. So Donnie, I'm on to you. I would bet dollars to donuts that it was your smug little self sending these anonymous questions. Anyways, it doesn't really matter because we exactly replicated Tomkins' methods with other organisms as controls, and we showed that his methods do not work, be they the 2015 and earlier or 2018 plus.
This is from Gutsick Gibbon. She says, one last question. If there is time, Dr. Tomkins, is there a reason why you switched your methods from ungapped and weighted to gapped and unweighted from 2015 onward?
Yeah, I wanted to include make the alignments longer. When evolutionists first began comparing human and chimp DNA, they actually did not gap the algorithm. The algorithm itself has been improving significantly over time, especially, like I said, since I first began using it. And actually, the algorithm was improved based on my own complaints and interaction with the NIH and sending them data and, from my analyses and convincing them that they needed to fix it. But so the algorithm has improved over time where I could include better alignment features in it, increase the length of the alignments by allowing for very liberal gapping. But the algorithm's limited. Once it hits a gap that's so different or so big that it can't get through, it breaks off the alignment.
So my understanding is that ungapped was used extremely early in the comparisons between humans and chimpanzees, and that it was acceptable at the time because they were comparing protein coding regions, and proteins tend to be highly conserved between organisms. Still, I don't think they would do that now, and in fact, using ungapped for any two different species, and even two members of the same species, if the regions of the genome being compared are too different, gapped is recommended. So the logic here is sound. He's saying earlier on we were using shorter sequences, but I wanted to use longer contiguous sequences, and so the switch from ungapped to gapped was merited. Except he was using like long contigs pretty early on in his sort of series of papers on this topic. In fact, he did the entire genome, or at least enormous portions of the genome, back in 2013 and then in 2015. So ungapped was not appropriate then either, and he seems to understand where it is and isn't appropriate, so I don't understand why he used ungapped ever at all, except, again, kind of calling back to this original methodology back before we knew too much about using BLAST or even comparative genomics in general. Now, the second thing that's weird here is he talks about how he switches to using gaps, but it's okay because he used really liberal gapping parameters. And none of that matters because, again, he doesn't weight his sequences. So, like, it goes from being a more understandable genetics mistake through time to being a worse mistake because it's something that like a middle schooler would understand.
So I'm just trying to improve my research over time, I guess would be the answer to that question. And and increase my, alignment, the alignment capabilities of the tools I'm using, because I want to get to the bottom of it as much as anyone does. So,
yeah.
Go to the comments now and tell me, do you believe him?
Yeah, it's just been a long process, a long haul, and basically what I've shared tonight is the most up-to-date assessment that I can give you at this point. So, maybe in the future I can have even more data to share, hopefully. So,
well, Dr. Tomkins, you've done some great research over the years. We're so grateful for your contribution, and we're about more than 15 minutes over. So
the most up-to-date personal research he seemed to show in this video, at least with regard to the human-chimp genome similarity, was from 2018. And as you saw earlier, and as we've talked about today, the field has advanced quite a bit in the past 5 years, in the past half decade, to say nothing of the fact that his methods were never appropriate to begin with. So that ends my little inserted portion here. Let's get back to your regularly scheduled conclusion. My gentle and of course very modern apes, thank you so much for being with me here today. This one took a lot of work, so I really appreciate you guys sticking around through my nonsense arc in order to see some of the bigger projects that I have to offer. And indeed, I've got 2 more at least that are very close to being released. They're down the pipeline. They're on the way. But in the meantime, if you like what I do, you can like, comment, and subscribe as your free way to support me. And if you want to support me in other ways, you can join my Patreon, where you get sometimes early access to videos, and every time you get your little name at the end when the credits roll to my little animation, and to Brock Berrigan's really cool song, Point Pleasant. I hope you enjoyed this video, and I hope that you will now go forth into the world wielding the knowledge that humans and chimpanzees really are 96 to 98.8% similar, and that 80% number is complete and utter bogus. And my promise to you is that no matter how long Jeffery Tomkins stays on this subject, I am now like a hound with a scent. I will not ever stop correcting Jeffery Tomkins' mistakes on his genetics work. I don't care how many experts I have to contact. I don't care how long it takes me to run the analysis. I will make sure that I peer review him forever. And I'm sure my biologically inclined viewers would also like to give you their thoughts, their free peer review. So folks, if you would like to give Jeffery Tomkins, whose email is public, your thoughts, you can do so by shooting him a message here. Do not harass Jeffery Tomkins. This is me encouraging you as my audience to give him your professionally worded, appropriate, and civil thoughts on his work, not heckle him. The former is supposed to be welcomed at Answers in Genesis and ICR, so I don't think that will be a problem, will it? You can feel free to send him my video or just ask him any questions that you have about his work after having seen most of it, with regard to this topic at least. And so, my gentle and of course very modern apes, please do take care of yourselves, and I will see you next time.